Hello, welcome to this session of our revision for the GCE. In number 6, a spring balance reads 36.4 newtons when a mass hangs from it in air and 32.0 newtons when the same mass hangs from it in a liquid. The upthrust on the mass in the liquid is, so generally what you should know is that the weight in air would normally be equal to the weight in liquid plus the upthrust force. So when you place the mass in a liquid, the liquid would exert an upward force on the mass, and this upward force will reduce the resultant force that the spring balance will read. The reduction in the weight of the mass corresponds to the upthrust that is exerted on the body by the liquid. And so upthrust should be the weight in air, which is 36.4 newtons, minus the weight in the liquid, which is 32.0, and that gives 4.4 newtons. So the upthrust is 4.4 newtons. In number 7, the acceleration of a body is defined as A, the rate of change of displacement. No, rate of change of displacement is the velocity instant. B, the rate of change of velocity. Yes, the rate of change of velocity is the acceleration. Now in C, the rate of change of displacement with time. This is simply a detractor. It is a detractor because a rate already denotes time, and when they add again with respect to time, it doesn't make sense. Now the rate of change of velocity with time, you see in the beginning of the section they said choose the letter that corresponds to the best answer. So the best answer is the rate of change of velocity. D, the rate of change of velocity with time, is a tautology, so the statement is not the best option. B is the best option. If B, the statement in B were not there, you could then be managing with D. So the fact that they added with time makes the statement not the best option because rate already denotes time. In number 8, a graph of velocity is plotted against time for a car of mass 800 kilograms moving from one station to another. The area under the line and the time axis gives A, the acceleration of the car, B, the average speed of the car, C, the distance covered by the car, D, the momentum of the car. So in cases where you have to determine the significance of a physical quantity calculated from the graph, most of the time it has to do with the area enclosed by the curve or the slope or gradient of the graph. In the case of area, just take the units of the vertical axis. The vertical axis is the velocity because it's plotted against time. So velocity, the unit is meter per second, the SI unit. You multiply it by the unit of the horizontal. They say against time. So the horizontal axis would have time, whose unit is the second. When you multiply the two units, that's when you want to get the physical significance of the area. Multiply the units of the vertical axis by the units of the horizontal axis and you simplify. The second will cancel and we are left with the meter. So the resulting unit is the unit of the physical quantity that that area will represent, and the meter is the unit of distance. So C is the correct option. If it were the slope that they were asking the significance, you divide the units of the vertical axis by the units of the horizontal axis, and then look at the resulting unit, which would then give the unit of the physical quantity that is the significance of the slope. In number 9, during a football match, a boy of mass 60 kilogram running at a velocity of 4 meter per second, it should be per second, not per second squared, collides with another boy of mass 70 kilogram running at a velocity of 3 meter per second towards him. The total momentum of the two boys before collision in kilogram meter per second is, so to have momentum, first the definition, momentum is mass times velocity. Momentum of the first boy would be the mass 60 into the velocity, which is 4, plus they want the total momentum, so I have to add to the velocity of the other boy. But you have to be careful here. They said the other boy is running towards, so the second boy is running towards the first. Since they are in opposite directions, momentum being a vector, we need to change the sign. So the momentum of the second boy will be negative, and we are multiplying the mass 70 by the velocity, which is 3. So we get 240, the momentum of the first boy, minus 210, the momentum of the second boy, which gives 30 kilogram meter per second. corresponding to option A. In number 10, a body is accelerated from rest with an acceleration of 2 meters per second squared. When it has traveled a distance of 9 meters, its speed will be. So in this case, when a body starts from rest, it's a key word in the question. When it starts from rest, the initial velocity u equals 0. And in this question, we are looking for the speed when the acceleration and the distance has been given. So the best equation to use is v squared equals u squared plus 2as. We are looking for the final velocity v. So v squared will be equal to u squared. U is 0, so 0 squared plus 2 into the acceleration, which is 2, into the distance, which is 9. So v squared would be equal to 4 times 9, which is 36. So that v would be the square root of 36, which is 6 meters per second, corresponding to option B. Thanks for watching, and see you in the next part, in which we will be covering questions 11 to 20.